Hello everyone, this is Sakti Sarup Chaudhary. Well, in this video, we are going to talk about what is measurement, why it is important, and what is accuracy and precision in measurement, and like what is its relevance. Sometimes we think of what is error and what are different types of errors. Suppose there is a calculation yet to be needed in error, so how we deal it. So in this video we are going to talk all about all of these things. This video is quite useful for 12th class peoples plus 11th class peoples. Sometimes it is also useful in research areas also, and this is a very basic course. For in details analysis we have to go for statistical things. So let's get started. So what is measurement? Well, the question arises how we quantify any physical parameter. We quantify any physical parameter by measurements. For example, when we talk about temperature measurement, we talk in terms of degree Celsius or Kelvin or Fahrenheit, etc. Similarly, for weight measurement or mass measurement, we go for kilogram, gram, etc. Similarly, for length measurement, we go for meter in SI unit, and for time measurement, we talk about in seconds. Accuracy and precision are very important. So, accuracy is the measure of how close the measured value is to the true value, and the precision tells about at what resolution or limit the quantity is measured. So now let's think about an experiment. In this experiment, everybody is trying to shoot with a gun with these concentric circles. If somebody shoots in the center part, then he wins. But due to some instrument error, every time when somebody aims at the center, it deviates from the center and hits in a particular region. So in that region, it is said that it is precise, but we are not accurately hitting the target. But meanwhile, if some new learner comes and hits the target, then definitely the target will be scattered. So this scattered result gives a neither precise nor accurate reading, like as shown in the figure. But suppose the person or the archer or the gunman wants to hit to the accurate part, but accidentally it goes nearby accurate, but all the readings are not falling on the accurate domain. So therefore that region is known as accurate but not in precise, like here. And if we want to have an accurate and precise both, then we have to get the readings, all the hits in the inner circle itself. So in this picture we can see all the readings are in the inner circle, so which is accurate and precise. The accuracy and the precision can be also explained by statistically. Well, when we talk about the distribution of the measurements in terms of Poisson's distribution, so if the mean distribution is much more wider, then it is not precise. But if it is a narrow one, then it is precise. And the mean value, if it corresponding with the true measured value, then true value, then this is an accurate one. So in the figures we can determine with statistically that the measured value is a precise one or accurate one or both or neither of it. Well, the main purpose of representing any measurement in a Gaussian distribution is that there is an uncertainty in any measurement. So how hard we try, we cannot achieve a 100% accurate measurement because of instruments has some limitations. human has also some limitations. Although if we use any machines, it has some limitations. So every result has some uncertainties. These uncertainties are called as error, and these errors are divided into two types. One is systematic error, another one is random error. When we talk about systematic error, the error due to instruments, the error due to imperfection in experimental technique, some personal errors, these are actually categorized into systematic error. Well, in instrument errors, the errors may be, best example is zero error in vernier caliper. Sometimes we cannot, due to manufacturing defects, there will be some errors. Suppose we are measuring in a wrong way, that is also called as imperfection in experimental technique. Sometimes person, so I am measuring suppose and I am measuring it wrongly, so there is personal errors. So this can be removed with proper precautions. The proper precautions are improving experimental technique, selecting better instrument, and removing personal bias such as defective, suppose parallax error or something like that. Well, the random errors are those errors which cannot be regulated and comes irregularly. We can say in other words, we cannot predict it. The error cannot be predicted, and these are for example, there is in fluctuation in temperature, suppose plus or minus 2.2 when we measure. Suppose there is a voltage fluctuation while measuring, mechanical vibration, etc. Least count error is also one of the random error because we cannot avoid it. So least count is nothing but the smallest value that can be measured by measuring instrument. For example, we are measuring a 0.1 micron meter with a 5 millimeter scale. 5 millimeter scale has suppose least count 1 mm. So 1 mm cannot measure this 0.1 micron or 5 micron. That's why least count, by using the proper least count in the scale, is one of the most important criteria. When we talk about error calculation is done mostly, we can classify the error calculation in two terms. One is absolute error, another one is relative error. When we talk about absolute error is the magnitude difference between the individual measurement and the true value of the quantity. Whereas relative error generally denotes the error delta mean, which is an absolute error divided by the mean value. Suppose we started taking measurement and we take measurement as A1, A2, A3, AN. But how we will take the mean? It's very simple. You have to just sum it up and divide it by the number of measurements. So after getting A mean, when we go for absolute error of the first measurement, then we can just minus it and we will get it. Similarly, for the delta A mean, which is a summation of all the absolute errors. Well, when we talk about relative error, just take the delta mean divided by the mean value of the measurement. That's how we calculate the absolute error and relative error. When we represent any physical parameter or measured value of a physical parameter, we generally represent as A mean plus or minus delta A mean, which is absolute error over here. So hence there are some rules for the calculations also. For example, some arithmetics, which is addition, subtraction of absolute errors with the final result, is the sum of absolute errors in individual quantities. When two quantities are multiplied or divided, we talk about relative error. Relative error is a result of summation of relative errors of the multipliers or divisions. So let's analyze it. Let's talk about, suppose we have two physical quantities, which is A and B, which has relative error delta A and delta B. Let's consider z equals to a plus b, and the error in z is delta z, which will come as sum of absolute errors. Well, let's prove this. Well, it's very simple. For z equals to a plus b, z plus delta z, which will be associated with the error which we are going to determine, will come as a plus or minus delta a plus b plus or minus delta b. If you take the maximum value difference between these two terms, will come as delta z equals to delta a plus delta b. So the maximum error in z will be delta z. Similarly, the minimum error will also come like this. We are considered our maximum error. So for z equals to a minus b, suppose we are talking about negative term while subtracting. While subtracting, this error should subtract or not. But still here also we can see the maximum error during subtraction will be a plus delta b also, because although these two parameters will be subtracted back, but these I don't think there will be subtracted to get a maximum error. If you subtract, then it will not be the maximum error. So now let's talk about, in case of multiplication, how we calculate the error. There are two physical parameters as like before, a and b, and the ultimate parameter is z. So z plus delta z, which is delta z is the absolute error. We need to find it out. So we have to multiply it. When we multiply it, we'll get it like this. When we expand these two terms, so it will be expanded like this. And now let's do a tricky. Let's divide this z into both sides. Z in left hand side and ab in the right hand side. So we'll get a terminology like this. In this terminology, can we figure it out? These terms resembles with relative error, isn't it? And we simplify it further by taking delta a by a multiplied by delta b by b as near to 0, because this is one small term, this is another small term. Small term into small term is very much less than 0. So that's why we are neglecting this. So here the ultimate relative error in multiplication will come as the summation of relative error of a and relative error of b. So similarly, if we calculate for division, it will also come, this one is as the maximum. So either it is addition, either it is a multiplication or division. The maximum relative error will be the summation of both the relative errors. Now, what if there is a physical quantity which has a power of k? For example, z equals to a to the power p, b to the power q divided by c to the power r. Then nothing to do, we will follow the same principle as of the last time, but here we have to multiply this term over this here, like this. So this will come ultimate values of the relative error z. So with this I am finishing this video. Thank you for listening. There is a proverb, perfection is a polished collection of errors, by Mario Benedetti. So with this, see you soon guys. Please like and subscribe. Thank you.